But they don't give us the beautiful Doppler formula? Yeah. 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 Yep. What units though? That's right. The I don't know what do you get when you go 691 minus 656? $35. So we still have 2 sig figs when we do this. Say it again. When you add or subtract, right, if you go minus 25, right, and there's no decimal point, right, the rule is, and IB no longer says we need to teach this rule, which is 10 to the 9th. There's 10 to the 4th. I love that. Yeah, that works, right? They say we don't need to teach this rule, right? But we've got these 2 numbers. The rule is that if we don't know the 10th place, we never do, right? That's right. Subtracting is not going to give us a magical knowledge of the 10th place. And so this is 2. We go from 2 sig figs to 1 sig fig, right? And this makes sense, really, if you think about it, because you couldn't say 2.0. We have no idea about that 10th place, right? Now, if it was, well, then you could say 0.0, right? It's the least, you round the least place. And that's because if you're subtracting, you're getting down to the you're getting down to a little more, the uncertainty is a greater part of the number, right? But, are we ready for a right arrow?
Yes.
Meanwhile, back at the ranch, okay? Edwin Hubble uses the 100-inch telescope on Mount Wilson to look at spiral nebula. He knows that they're galaxies. Huh? He sees in those spiral nebulas, he can pick out individual stars. He can find Cepheid variable stars. He can measure the distance exactly. Because Cepheid variable stars are variable stars whose brightness is related to their period. Bright stars oscillate back and forth slowly like large gongs, right? And smaller ones that aren't as bright go more quickly, okay? So he finds Cepheid variables in these galaxies. Is 100-inch, when we talk about 100-inch, what are we talking about there? Do we know? Is that the diameter or is that the length of the telescope? It's the diameter, yeah. We don't give a flippin' rat's. The length of the telescope. In fact, telescopes don't even have tubes, right? They're just like, they'll just stick something there and something there, and right? You could buy telescopes that aren't surrounded by tubing. In fact, they do that because then you get more air in there. The mirror has to cool down, right? This is one of the things. And the Mount Wilson telescope is this monolithic block of glass. It's got to have a mass of many, many tons. And that's a liability because when you tip it up on its edge, it sags a little bit, and then it's not perfect anymore, is it? Right? Unless you've got a structure that'll hold it up. So in Tucson, they actually when they make mirrors, this shape of the mirror is a parabola, right? And what they do is they cast it in a spinning kiln. The mold sits there and spins, and just like a bucket of water, it'll form a parabolic shape that's approximately the right shape, right? And what they've discovered in Tucson is that they need to make these mirrors. They don't cast them as solid glass. They stick stuff in here, right? So it's like honeycombed, right? It's just as strong or nearly as strong, but it doesn't have the weight. So they'll fill that space with a lot of stuff that they can then just sort of chip out of there, right? And then it's much more lightweight. It's much more able to hold its shape. And then here's a cool thing. You can circulate air through that and change the temperature of the glass because it needs to be the same temperature as the air. If it's not, there's little convection currents on the surface that screw up the light because the index of refraction gets screwed up, right? It's like, like when you see a hot road, that shimmery stuff, that's convection currents. That's less dense air and more dense and all that stuff, right? You want it perfect, all the same temperature, air not moving, etc., right? Okay, so 100 inches means that this is 100 inches there. Not a particularly large telescope now, right? We've got like, meters of stuff, right? 30 feet across and stuff like that, right? But 100 inches is pretty big, isn't it? Am I 100 inches tall? No, I'm not exactly right. It's like more than 8 feet, 4 inches more than 8 feet, right? Because a 2x4x8 is 96 inches long. Yeah? Carpenters know all the multiples of 12, right? 96 is 8. Okay? So yeah, you could stand up inside there and walk down there. It's this huge thing, right? Why do we want 100 inches? There's two reasons why we want a 100-inch telescope. Better.
It catches all the light. Catches more light.
Yeah, be careful about magnification. You are able to go to a greater magnification and see a more crisp thing. One reason is light, right? The bigger it is, the more light it captures, and when you concentrate that, you get a better image, right? Okay. So be careful if you're using your telescope to look at the sun. Did I tell you this story? There was an 8-inch telescope here at the school that everybody just said, well, we don't want it. So I said, I'll take care of that telescope. I'll find a good home for it. My garage. Yeah, right? The mirror was covered with dust, so I found an ingenious way to clean the mirror. I suspended it from the ceiling. I thought this was ingenious, right? Suspended it from a ceiling with a string, right? Because it was on a cardboard base or fiberboard base that couldn't be immersed in water, like you see on the YouTube videos. So I suspended it face down in a little bucket of warm, soapy water. Yeah? And then I just spun it. I just let it spin around and around. That took almost all the dust out, just the friction with the water. And then I just reached under there very carefully and loosened up the last little bit. Because you don't want to scratch it. It's almost better to have a dirty lens or a dirty mirror than to clean it badly, right? And then put it back in there. And then I was looking at things, and then the story was that a teacher previously taught at this school tried to look at the sun with it, right? Now, an 8-inch telescope concentrates a lot of light. So think about the sun concentrating in there, right? If you do that, what you want is something that covers the telescope. Here's the telescope, right? You want to put the cover here. You get these covers that cover the aperture of the telescope, yeah? What she used was something, because what it does is it goes like this. There is here there is a little reflector. Right? This is a Newtonian, right? So it concentrates here, right? Like that, right? And then it actually focuses here. And then there's an eyepiece. You ever see those ones with the eyepiece on the side? Right? That's what they're doing. This is a Newtonian, typical Newtonian thing, right? Okay. Well, golly. If you've got this, you can buy, when you get telescopes, they sell you really cheap little filters. They're like welding glass that you fit in the eyepiece here. Yeah? Those are for really small telescopes, and even then I don't ever recommend you use them. Right? Because what happens if that cracks? Yeah, it burns a freaking hole in your eye, right? You just concentrate. Have you ever burned ants with a magnifying glass? Yeah, this was like I spent like 10% of my youth. I'm very sorry for all the souls of the ants that I've injured. Okay, it now violates my spiritual beliefs to do this, but I didn't have any problem with that in junior high, right? Okay, but that's what you're doing to your eye. Only even more. I mean, nobody has an 8-inch. Wow, that's a big magnifying glass, right? Okay, so this telescope purposely does not come with one of those because it's dissipating all that heat. It's a serious amount of heat, right? And so I'm looking at the eyepieces, the cheap little crappy eyepieces that come with the telescope, and I look in one and there's this gooey stuff in there, and I'm like, why is there gooey stuff in there? And so I reach in there and it's not gooey, it's plastic that has been melted. She freaking melted the eyepiece, the plastic mounting thing. She melted that. Right? This should have been a clue. And then eventually that thing cracked and she did actually burn her retina. So I wouldn't use this for any telescope of any size. The ones you want to use are the ones that cover up. They cost $100 or something, and there's really good ones that cover up the aperture of the telescope. And then, do you want to make sure it doesn't fall off? Yes. Yeah. Kind of. It's kind of like the harness when you're climbing in the gym. It's like if that falls off, it's going to burn your freaking eye out. Okay. So yeah, make sure the sun is a very cool thing to look at. It's easy to find too in the sky, right? Okay. But there it is. So the reason number one is that it collects light. Just be careful with that. Even the full moon is too bright for an 8-inch telescope. You're like